Hey, what's up, everybody? This is Coach Sharf, and welcome back to my Algebra 2 or Advanced Algebra notes videos. Today we are focusing on what used to be Unit 5, now is Unit 2. Who knows what it'll be 5-10 years from now if I'm even still using this video. But right now is Unit 2, exponential functions. And we open with our first lesson talking about E, Euler's number. And E is a constant that we use when we're talking about continuous growth. Can be bacteria, it can be a investment in a bank account. It's a constant, kind of like pi. Stands for about 2.718. And there is a specific continuous compounding formula that's different from the regular compound interest formula that y'all may remember from Algebra 1. So that's what our focus is on today. We're just going to do some examples using that formula. So first thing I'm going to do is share my screen. And we are on the student reproducibles for this first lesson. So if y'all were in class when we did this, it was diagnostic, just seeing what y'all remembered about. Got too many screens in the way. I don't know if this is doing what I want to do. Seeing what y'all remembered about. There it goes. About exponential functions. And then I just said E is kind of like pi, so we did this. Which one doesn't belong? It was the number 1, because all the rest, E, pi, and the square root of 5 are all irrational numbers. So again, our focus is on E. It's a mathematical. We'll start down here. E is a mathematical constant approximately equal to 2.71828. Again, kind of like pi. We use it to calculate stuff. I'm going to show you where E is in the calculator. But you need to have this formula down just in case you don't. If you're watching this because you have the worksheet in front of you because you missed the days of class when we did this and are going back to do it. The formula is A equals P times E to the RT power. So that's the formula. All this tells you what everything is. A is your final amount at the end. P is your principal, spelled like principal, like Dr. Buff, but all it means is the amount at the start. And usually that refers to money, but can also refer to other things as well. Again, E is not a variable. It stands for 2.71, but you don't have to try to calculate it. Don't have to try to calculate it like you do with just using pi is 3.14. So I'll show you where E is in the calculator. R is the interest rate. So problems where we're investing money, it's the interest rate. Other problems, it's just the growth rate that's given. And T is your amount of time. Again, we're talking about compound interest. It's usually years. Some of the other stuff we're going to do is not going to be years. It might be days or hours, but whatever interval of time it is. Okay. So the first problem that we were given that we did in class, a student is studying the growth of a bacterial population in a petri dish. The initial population of the bacteria is 100 cells, and the population doubles every 2 hours. The growth of the population follows an exponential growth model. The student wants to calculate the population size after 6 hours. So the first thing it tells you is, or the first thing you should pick up is follows an exponential growth model. You know there's going to be some kind of exponential growth. If we graphed it on a graphing calculator, it would be that curve. I got to try to do it the other way because I'm flipped. But it starts off kind of slowly, and then as you continue to go to the right and go to the right, it starts to go up higher and higher and higher, right? So that's what it is. So we actually want to calculate what it would be based on this curve. Based on the information we're giving us, we could do a very quick estimate, okay? So start with 100 cells, doubles every 2 hours. It means after 2 hours, it would double to 200. After 2 more hours, which is 4 hours total, it would double to 400. Then after 2 more hours, which is now 6 hours total, it would double to 800. So we should be getting 800, okay? It's got some assumptions here, but again, that's all those assumptions are just ensuring that our growth rate can be constant and is not going to change. Okay. In this case, it's the conditions in the petri dish, making sure that the temperature stays the same, bacteria has enough nutrient concentration to grow, things like that. So the given information, you start off with 100 cells. The doubling time actually doesn't matter. Total time it's growing is 6 hours. The growth constant K for the bacterial population is approximately 0.347. Using the compound interest formula, it's actually the continuous compound interest formula that we saw above. Use what we are given to determine the population size after 6 hours. All right, so where's my whiteboard? I wonder if I can't pull it off because I'm screen sharing. Let me stop sharing. Let me see if I can figure this out. No, your whiteboard's here. All right. So I guess I had to stop sharing. All right, so they really made this kind of fancy, haven't they? All right, so we know our P is 100. Our K, which is our growth rate, which is what we're going to put in for R, is approximately 0.347. And our amount of time is 6 hours. Okay. Again, now it's hours, not years. So what we're going to do is we got to take all the information that was given to us and plug it in the formula. And when y'all are doing the worksheet, y'all are going to have to show me actually plugging these in the formula because that's really all the work you can show. There's no steps to work through. It's not a long algebra problem. You're just going to be punching this into the calculator after you plug it in. I can't change colors. All right, cool. So I was trying to get blue, but it's fine. All right, so A equals 100. As a 100, I know it's my zeros are kind of close to my ones. 100 times E to the R is 0.347. We want it as a decimal, so we're going to go ahead and do that times 6. Okay. So this is our formula filled in. Now I'm going to show you this, but it's going to be written slightly differently. So what I'm about to put in red, if you have one of the school calculators, I got the blue one that was laying here. Most of them are the pink ones, but they're exact same calculator. What I'm about to write is what your display should look like. Okay. What your display should look like. It's going to look like 100 times E to the, and it's going to be open parenthesis, 0.347 times 6. Okay. But how do I get E? All right. How do I get E? I'm going to show y'all on the calculator in a second, but I need my screen big so y'all can see it. But the E to the in the open parenthesis. So this part specifically, you're going to get by hitting second and then the LN button. Okay. So second is in the top left-hand corner. Underneath that is log. Underneath is LN, which represents the natural logarithm. So you're going to hit second LN. And if you look above it, I know y'all can't see it right now. I'm about to close it out and see if it's bigger. You'll see the E to the X. Okay. So those whiteboard. There we go. All right. So we're going to do 100 starting with that. I know it's backwards, so y'all just gonna have to follow me. Times, again, second ln, if you could see, and I'm trying to get as close to the camera as I can, that's e to the x power. I know it's flipped, but it's e to the x power. So you're gonna hit second ln, e to the pops up, 0.347 times 6. I know it's flipped. I don't know if I can, there's a way to flip the camera. I'm not. So we got it in here. We're going to hit equals. And it's kind of hard to see, but it's 802.4. It's flipped upside down. Okay. It's 802.4. Somebody knocked on the door and they walked away before I get up. Okay. Maybe whoever it was didn't see me back here. I don't know. All right, pulling it back up. All right, there we go. So when you punch all that in, like I said, you're gonna get 802. It's actually 0.049. I didn't show that. So we'll round that up 2 decimal spots and be 802.05. So we actually got slightly above 800. And since we're right at 6 hours on the dot, we should have gotten 800 on the dot. My guess is this was actually a slightly lower, maybe like 3, 4, 6, 8. I'm just making one up, but something like that. And then they just rounded up to 7. So it wound up actually being slightly higher than our 800, but we know we were looking for about 800. So we know we got in the ballpark. This is the point on that. All right. So with bacteria are living things. Okay. So in my opinion, we treat bacteria like we would, if we were measuring a human population or something. So if we're told we have, I'm just going to add 10,000 in front of it. So there's 10,802.05 residents of Covington. You're not going to see 5% of someone. So you're not going to see, the lower part of somebody's leg chopped off, below the knee, just walking around on its own. That might even be slightly bigger than 5% of somebody's body, but you get the point. You're not going to see 5% of somebody's body just walking around on its own. So we know we have more than 802, and even though it's just that small fraction, I've always just rounded up to the next number. So, if this were human population, I would say 803. It might depend on test estimator. I think most are kind of in agreement with that. They would round up to the next number. You might see 802. You're probably not going to see the decimal though. If we're talking about human population, be either 802 or 803. Bacteria, I've seen all three. Since it's 05, they just cut it off at 802. Following my logic, they go ahead and round up to 803, or they just leave the decimal. So it might just kind of depend on whoever makes the question. The thing I'm going to say about it is you're not going to have multiple answers. So you're not going to have 802 and 802.05. You're not going to have 802.05 and 803. You're not going to have 802 and 803. So in a multiple choice setting, you should know which one to pick. But where y'all just providing me the answer on your own, as far as bacteria goes, if you want to leave the decimal, I'm okay with that. Problem number two. And I gotta figure out if I can clear this or do another page. I can really change this up. Let's see. Let's show more tools. You're not gonna let me clear it out. Not to spare under this process race. That's laser. All right, I'm not gonna sit here and waste too much of the video figuring out, so I'm just gonna close it and do another page, I guess. All right. So problem number 2. I'm actually gonna try to write this out very quickly if I can. Okay. The problem number 2 was a similar problem I did with bacteria. So I said we're gonna start with your growing two bacteria in a petri dish. Again, it doesn't have to be petri dish. By the time y'all have seen this, we've done the lesson on bacteria in the swimming pool, wherever bacteria can grow. But we're saying bacteria in a petri dish. Oops. Growth rate. I keep wanting to write letters before I get to them. I don't know what I'm doing. The growth rate K is 0.163. How many bacteria will there be in 120 hours? Okay. How many bacteria will there be in 120 hours? So we're still using the same formula. So we got to identify P, R, and T. Okay. There's the eraser. I had to click on pen. There it is. Yeah. All right. So P is 2. I'm going to put K, which is filling in for my R, is 0.163. T is 120. Why did I use 120? Well, 120 hours is 5 days. So I was kind of thinking along the lines. I'm actually going to do a problem similar to this here in a minute because you can have a couple on the worksheet. But I was thinking along the lines of I was thinking along the lines of if y'all have probably seen problems like this before, if you have kids, come to school on Monday and 5 of them have the flu, and how many ever more whatever percentage more kids get the flu throughout the week, how many kids have flu at the end of the week? That's kind of what I was thinking, but we'll actually do a more similar problem to that here in a minute. Focusing on this, all right, we're gonna get A equals PERT. Again, you need to fill it in. So 2 times E to the 0.163 times 120. Okay. You need to go back a few minutes. If you need a tutorial again on how to punch it in, go back to that first problem, but I'm not going to waste time showing it on every problem because it's different numbers, but the same process. We're going to get E in the same way. Okay. Before I put the answer down though, because I already know what the answer is. Actually, I don't remember what it is exactly. I know what it roughly is, so I do need to calculate myself. I know what it roughly is, but before I calculate it though, or while I'm calculating it, let's kind of explore. It's going to be a very big number. Okay, you would probably, you'd have been shocked and you'd have thought there could have been there's no way this is right without me telling y'all that it is. If you're just doing it on your own. Okay. So what y'all need to realize is 0.163 is just under 0.166666666 repeating forever, which is the decimal equivalent of the fraction 1/6. Okay, so that decimal roughly represents 1/6. So I have 1/6 times 120. 1/6 of 120 is 20. So when I multiply those together, we can, if we're trying to do a rough estimate, it's 20. So I have E to the 20th power. Again, we know E is, even though you have the button in here to do it, we know it's about 2.718. So what you're saying is I have 2.718 times itself 20 times. And then I'm multiplying it one more time by 2. So that's going to be an incredibly large number.
Hey, you're up, Sandra. Thank you.
Okay.
I'll give you the observation. I'll put it in observation.
Okay. Thank you. That was out of both. Y'all couldn't hear that. Anyway, so 2.718 times itself 20 times, and then multiplied by 2 again. So that's going to be an incredibly large number, right? So we got 624 million. 624 million. 928,112.2. I'll put the 0.2 because that's what's in the calculator. So 625 million roughly just under that bacteria. So we've gone from 2 bacteria to 625 million bacteria in 5 days. I wasn't trying to get a number that high, but that's pretty gross, right? Though I kind of, again, by the time y'all see this, everybody should have seen the beginning of the next lesson. We're talking about bacteria in the pool. When I extrapolated that out, with that first problem, if we were transferring it to a Olympic size swimming pool, which is, I use the competition swimming pool at UGA as my example. They have 844 gallons of water times 96,000 bacteria in a 2 cubic centimeter cup, and we were saying about, I think it's a little less than 500, maybe 300 of those would make up a gallon. It'd be over 2 trillion bacteria, if I'm reading this right. So yeah, bacteria are gross. All right. Problem number 3. Let's see now. Okay. Let me do a mass erase or not, but I probably should have done another slide, probably been easier. Whatever. I'll just erase the word problem. I'll leave the rest, I guess. All right. So number 3. Now we're going to talk about disease spreading through the school, because y'all have a couple problems like that on your worksheet. I used the flu for one problem. I was about to use COVID for another problem, but I didn't know if that was 100% kosher to do yet. Still might be a sensitive subject for some people, I suppose. So I changed it to zombie bites. Okay. So y'all got flu and zombie bites on your worksheet. So let's do chickenpox. Okay. So we're gonna say 10 kids come to school Monday with the chickenpox. All right. It was all one class there at one birthday party. The previous Friday after school, one kid had it and didn't realize it, and then 10 of them got it. Okay. So 10 kids come. We won't say all in the same class because then you might be able to that. They're all in the same grade. They've had different classes before. Let's pretend it's like a 3rd grade in elementary school. 10 kids come to school Monday with the chickenpox. It spreads at a rate of 0.65 per day. How many have, I'll put CP for chickenpox, at the end of Friday? Okay. So our starting number is 10. Let's go a different color. Starting number is 10. Spreads at a rate of 0.65, so we'll leave it as our K, which is still our R, 0.65. Now T instead of hours, spreads at a rate of 0.65 per day. How many have at the end of Friday? I thought I put 5 days. So if it's Monday, end of the day, Friday, we're assuming that's 5 days. All right. I think I did put in the ones on your worksheet. Maybe I didn't. I don't know. But beginning day, Monday, end day, Friday, we're going to say 5 days. Okay. So again, we're just going to plug those in here. 10 times e to the 0.65 times 5, which rough math in my head is going to be in the 200 range, I think. Actually just punch it in the calculator and see. So 10 second ln gives me e to the 0.65 times 5. Yeah, I was right. 257.9. It's 0.903, so I'll just put 0.90 for that sake of it. But again, this is actual people that we're talking about, humans. So we're saying 257.90 kids. You're not gonna have 90% of it, a kid who 90% of them has the chicken pox and 10% doesn't. So, normally if we round up the next whole number, obviously this would go ahead and round up anyway, but go ahead and make it 258 kids. That's a very, very high contagion rate. I mean, think about it, most elementary schools have maybe 500 kids at most, so and that's about half the school gets the chicken pox in a week. Yikes. All right. The last problem, and I don't remember this is the problem I used in the previous video. And this isn't the ones that we used in class, because the ones in class, I changed the second one from class to class. I think I did different numbers, different interest rates, things like that. The first problem we did was all pretty similar. It was you were trying to save starting January 1st, you were trying to save by the end of November to buy a PS5 for yourself or significant other or whatever. And most classes had the same interest rate. I think a couple had different ones, but so the two examples we did in class as far as money goes, I'm not gonna do that. So I'm gonna use a different problem. This might be the one from the first video link I put up, honestly, if I remember correctly. So we might even again, I'm not gonna, well, I can erase. I'm not gonna erase. We might actually revisit this in a couple weeks, but I'll go ahead and put the problem down here, and not everybody's gonna watch the video anyway, so if you haven't seen the video, you won't have seen this problem. I don't know how often I've mentioned it to get this set of 2023-2024 classes so far. But I worked at Publix for a while. When I was in college and then after college, and even my first year teaching, I was still working at Publix 2 or 3 days a month. And my first month actually teaching, before I got my first teaching paycheck, I was basically working 2 jobs. I was teaching, and then I was still 3 or 4 nights a week, and 1 or 2 days on the weekends I was going into Publix so I could still have money until I got my first teaching paycheck at the end of August. So when I was trying to actually leave Publix, I didn't get quite this high, but my goal is to have $5,000 worth of stock. So Publix is a privately held company. It's not traded on the stock market. Okay. So Publix is privately held, and it's owned by all the employees. So any employee, even if you just work 1 4-hour shift a week, is eligible to buy stock in Publix. Okay. There is a limit based on number of years you've been working, but everybody's eligible to buy stock. Everybody can also earn shares of stock by working, over a certain number of hours per year. It's also based on their income, but again, more than y'all need to know for this problem, but I had about $4,200 worth of shares when I stopped working there, and was trying to hold on to it for a little bit and to see if it would grow, because Publix has been continuing to grow and expand in states like, and they've been in North Carolina for probably close to a decade now, actually, but Kentucky and Virginia. But I was trying to hold on my stock, see if it would go up, and it didn't go up for a few years, and I probably could hold on to it, but I just went ahead and got rid of it. But I had about, I think, $4,100 worth of stock. I wanted $5,000 worth of stock when I quit, so that's what we're going to use. Okay, so we're going to say I have, and we're going to turn it into investment, even though it's not like stock. I invest 5,000 into an account with continuous compound. Again, this wording might be slightly different than the problems y'all see on your worksheet. So when we invest money, most investments, and even most times when you borrow it now, it's going to be compound interest. So again, what that means is, as you earn interest, the interest is automatically put back into your account, and then you continue to earn interest, not only on what you originally had in there, but now the new interest that's been put in. So it just builds and builds and builds and builds. When you owe money, same thing. When they charge you interest, they're charging you interest every month plus whatever fraction of your original amount of money that you borrow that you got to pay off, right? So there's different types of compounding. Again, we'll get more into this in a couple of weeks, but you can compound annually, which is once a year. It means they only calculate your interest once a year. Monthly is every month. That's actually what they do. When you have a mortgage or a car note, you pay it monthly. So that's what those do. If you ever look at your interest rate on a mortgage or a car note or whatever, when it tells you interest rate, that's over a whole year, right? So let's say it was 6%. So when they recalculate your interest every month, they're not charging you 6% interest on your outstanding balance every month. They divide it by 12, which would only be 0.5%, right? So you can have compounding monthly, you can have compounding daily. And again, this continuous compounding is actually going to give you your most money if you're investing. I can't honestly tell you an actual example of an account that y'all could go get right now that has continuous compounding, but in theory, okay? So I invest $5,000 into an account with continuous compounding. And then we're doing this over years. My interest rate is 16%. So where am I getting the 16% from? Again, it's kind of going back to a real world thing. I didn't hear this till about the last year I worked for Publix. All right. And this was a average over 45 years. So the average might have changed a little bit in the first 4 years I worked for Publix. And then I didn't work for Publix for a couple of years and then came back, worked for them more. But my last store manager said that if you go back and look over 45 years, again, a lot of this is probably going over y'all's head. It's fine. But because it's not relevant to actually doing the calculation, but I'm just telling y'all where I got 16% from. So between stock splits, if y'all know what a stock split is, the total value. So if all the shares in total are equal to $1 billion, I'm making that number up. When you have a stock split, the value of those shares doesn't go up. The total shares are still worth $1 billion, but if every stock was just split in half, it's designed to get more shares of stock. But if every share is split in half, then, if every share was $100 a share previously, now they're only worth $50 a share. So it's designed to get more shares of stock. And when you're growing, because again, you still got to give yourself some room to grow. The average rate of growth over 45 years, 16%. I might have mentioned some class last week. It'd be very hard to get that legally, or something illegal wasn't going on in a, just straight up, you're investing your money in an account that's not a stock. that has a set rate of return. All right. But we're gonna go with 16%. Okay. And when I stopped working, it was July of I already finished 1 year teaching, but it was July of 2017. I was 30. So let's say I'd gotten up to 5,000 before I quit, and I just wanted my account to sit there for 30 years. All right. Maybe I want to teaching a 31st year right now. I'm planning on teaching 35 because the way our retirement works. I mean, I'm only 20% of the way through that at this point, so we'll see about that. But let's say I want to hold it for 30 years. All right. So again, this is really going to give you all a hint on investing as well. So it's only $5,000. It's not like I'm starting with a crazy amount of money, right? The biggest kicker in all of this, so I scratch that out. Now this is just straight up interest rate. My interest rate is 16%. So again, when it's an interest rate, it's just 0.16. I got to turn it into a decimal. If you put 16 there, you're going to get, your calculator can't fit that number. Okay. So 0.16 time is 30. So we're going to have 5,000 times e to the 0.16 times 30. Again, go back and look at the first problem if you need to figure out how to punch that in a calculator. When you do that, I believe you're going to get around 607,000. Yes. Actually, I've done these. I promise I didn't look that up before I started. So I've just done these problems so much. $607,552. This is money, so we're going to go out 2 spots. It's 0.87, so we'll say 0.99 cents. Okay. So, the 2 problems I did in class, I honestly don't know if they gave y'all that much hope. In terms of investing, and again, this is, I can't tell you a specific example where you can get continuous compounding. The best you can honestly probably try to find is monthly, but I mean, most investments y'all would do would be annual compounding. Okay. But the interest rate is really the key here. The interest rate and leaving it invested for 30 years. So we've turned $5,000 into $607,000. All right. If you, in this case, even though there's a lot of math going on, if you just straight up doubled 5,000 to 10,000, it would still double your amount. So you could invest 10,000 instead of 5,000, you would double the 607,000 to, over 1.2 million. So that's yeah, I'm not saying this is attainable for most people in terms of making an investment, but gosh, if you could get that, you're going to be set. All right, so that should be enough examples to cover your worksheet. Let me stop sharing the whiteboard. Should be enough examples to cover your worksheet. If y'all got any questions, again, I'm recording, it's 3:08 right now. It's gonna take a while to upload to YouTube, so probably won't get this up till tonight, but y'all have until Friday to do it. So yeah, if y'all got any questions, send me a message on Remind. Otherwise, I will see y'all in class.